No,
non te muove.
Okay. So it's going to be in English. Is that okay? Okay. Let's speak in English. Okay, so my name is Luca Matteis, and I work here in Netherlands for Espresso. And today I'm going to talk. Is that loud enough? Is that okay? You can hear me?
Yeah.
Okay, so today I'm going to talk about state charts, and the title is Controlling the Behavior of Complex Systems. Okay. So the way that I got interested in state charts is actually because I've been interested in the subject that we're relating to the idea of how to make development of software more natural. And it seems like state charts allowed me to sort of answer some questions I had about this subject. And even though we've been like creating many frameworks and many tools, especially in the JavaScript world, it's been a sort of crazy, past maybe few years where we've seen like frameworks and tools are popping up and dying after maybe a couple of weeks. And so I was really interested. Okay, how is this really the solution? How can we make development seem more natural for us, for human beings? And specifically, I was really interested in reactive systems. So I'm going to try to define reactive systems. Reactive is not really, it doesn't really have to do with functional reactive programming, which is very sort of, famous nowadays because everything that has to do with maybe RxJS, it's not really what I'm trying to talk about here. What actually I mean, if you can read this sort of screenshots I made from another presentation. For me, a reactive system, so usually we think about systems as being transformational. So there's an input and there's an output, and we call these systems sort of black boxes. And in my opinion, a reactive system is much more complex than this because it sort of looks like a black cactus instead of a black box because it has many inputs and many outputs, but more importantly, it also has the concept of an output to the system is also an input. So it feeds back into it, and it has this sort of snowball effect. And in fact, at the bottom you can read that a reactive system is concurrent rather than sequential. It's real time rather than lazy. It's distributed rather than centralized. And so I was really thinking about how to make, again, software more natural to human beings, and I really found that reactivity is the key difficulty, as it says at the top. So again, I was trying to understand, why is it that, I'm sure all of you are, programmers, all of you have developed complicated systems, and it seems that I've been doing it for about, I would say maybe 10 years professionally, and it sort of seemed, okay, why is it so complicated? Why is it still such a drag every time I have to create something new? I have to work on an application, I have to understand how it works. There's so many things, and even though we've improved so much in the abstraction, right? From languages, we've been creating languages that are much more high level, much more familiar, much more natural, but it still seems that we have the same complexities as we had maybe 30 years ago. So I was really trying to understand why is that the case, So I asked myself, what are my recurring pain points? What is the thing that I always, this is the thing that is actually, making my life worse during my everyday developments. So I asked myself, is it the business logic? Is it that I'm using object-oriented programming rather than functional programming? Is it that I'm not following the right patterns? Maybe I have to use an observer pattern instead of an interface pattern. Is it the language, the tools? Is it the lack of types? And actually, for me personally, and again, before I continue, this is very biased, so I'm giving sort of my opinions on the subject. It's not science, it's just my opinion of what is the complexity of software development. So I seem to answer no to all these questions. It's not really the business logic. Sure, all of making use of functional programming ideas will make your software more usable, and it will be much better than, it's just by experience we realize that certain things are better than others. But fundamentally, what I feel is that these are, it's sort of like we're using better tools. Maybe you have you're building a building and you have maybe a better hammer. And of course, having a better hammer will make a better building. But I think there's some fundamental truth into how we develop complex systems that goes beyond all of these things. It's sort of like a truth that exists no matter what. It's sort of very abstract, but I hope you understand. So again, okay. So to sort of allow us to discover what are these complexities, again, trying to see what is the problem, right? What is it that makes our lives miserable in a way? I wanted to analyze essentially some reactive systems, such as a user interface. So a user interface is what I was talking to about before, that it's actually similar to a black octopus. You have many inputs, many outputs. The outputs of a user interface, feedback into it. There's sort of a snowball effect of things that can happen. An event might trigger an action that would also trigger something else. So that's what the reactivity I'm talking about. So let's try and analyze some of these examples. And here I have, it's actually a specification. It's a wireframe for a simple mobile application. You don't have to read the text. What's important is sort of the images, the steps that exist that were represented to see what's going on. What does this app do? The user can click this button. Then there's a dialogue of connecting that appears, and so we have this event, this click event. Then there's at the top there's another dialogue where it appears if the Bluetooth is disconnected. So you have other events that maybe signal the connection or disconnection of Bluetooth, and the user can drag here at the bottom. There's other events that happen when you change the position of the phone. It has to adjust, and so there's lots of things happening, and I'm trying to figure out, okay, what is we have all these different components, and it seems like even here there's another example. You have the user can pinch and zoom, they can drag, there's a dialog here that appears on the top of the page, and all these interactions between these different components. Just the last example. Here we have a wireframe that shows it's very raw, but essentially it shows how the user can navigate through this app, and what are the actions that the user can perform. And to me, actually, like after a little bit of study, and more than study, it's more intuition, I would say, is that what all these interfaces have in common is that there's events, right? So we have events everywhere. We have this huge amount of events that we have to manage. So deciding when events may or must not be triggered, to me, seems to be where most of the complexity lies. Okay. So this, in a way, can be translated to events orchestration. So orchestrating events, understanding when to trigger an event. Okay. So, for example, going back to a user interface, we should show the dialogue only if the checkbox was clicked and the background color is green and the login component is visible, but also nothing should happen if the request is still ongoing. So these are sort of everyday scenarios or specifications that we have a group of people that business people that decide how our software should work, and we have to make this work. And here, of course, we have all these things that happen. What we do is I really like this picture that shows it comes from a paper, actually, from a book of the creator of the Statecharts, actually. His name is David Harrell, he's a professor. And you can find the link of this book. And it's really interesting because it compares he calls them intra-object and inter-object. So the idea, you can imagine that these rectangles are sort of the components in a user interface. And it seems like right now we're stuck in this world. So we always try to work out how components work, but we never, when we put them all on a page, what's really where the complexity lies is actually the path, the scenarios between the components. So the events that are triggered and the reactions between the components. Does that make sense? Am I trying? Is it clear that I'm portraying as events being the complexity or event orchestration?
Can I ask a question?
Of course.
Question. So, do you think the problem is also due to the number of states that the application can actually be on? Because we used to study at the university, everything is a finished state machine, right? So you can actually represent every software as a finished state machine. But in this case you're describing here, there are so many events that it's difficult to track all the possible events that the machine can have and how to transition from one event to the other. So it appears to me that you're moving the focus from the events to the actual transitioning, from the states to the events that trigger the transitioning.
Yeah, okay, so you're actually leading into my, you spoiled it perfectly. But it is connected, and I'll show you how it is. I'm concentrating on the events because in a way, the states, I'll show you how, are important for a system to function, but they're sort of implementation detail. From a user land perspective, or from a user perspective, what matters is the events.
What you care
what
about
happens.
is the event, yeah.
Because the states, you can change the states, so it's sort of a black box in a funny way. It's abstracted, but it's very important, and that's how I'll tie it. Okay, so yeah, again, the main problem here, I'm trying to really see what the problem is event orchestration, and we have to deal with all these events. We have various components. That's to me actually really like the crux of the issue. You can put all these different components. Even React, you can imagine, of course, everybody's used to using React components. Like maybe you downloaded a bunch of already built components that do specific things. You put them on a page. But they never work because you have to glue them with other components. It's the connecting with other components that's where 90% of our job lies. We're not paid to rebuild a table or how to scroll. That's already done. You have to. What really is the problem is how the table works with the other components, right? Is that clear? Yeah. Okay, again. So I repeated this many times. So the pain points are your orchestrating events. Behavior, so the orchestrating events is actually the behavior of our software. It's spread all over our app. All these components have their own behavior, you don't know how to tie it together. And it's really hard to reason about, okay? So, introducing Statecharts, almost there. So in my opinion, again, very biased, they're just one way. I'm sure there's many other ways, but I've been using them for now maybe 8 months. And they provide a way of solving these problems of event orchestration, and they do that in a very visual way, and I'll explain to you what is a state chart. So, a state chart is actually a state machine. It's a state machine that has hierarchy, so you can have a state machine inside another state machine, and it has this concept of having, you can have multiple states at once. Usually a state machine has only one state. Here active states, yes, sorry. You can have multiple active states at once. And also there's this concept of history. So when you enter a state, the system remembers what state you're in. But these are just details. For now, all you have to know is that it's sort of a visual formalism for complex systems. It was created amazingly in the 86, pretty much, 84, by, again, it's a professor, David Harrow. And essentially what it is, it's drawing. Okay? It's nothing other than a diagram that can be drawn on a piece of paper, but it has specific semantics, so it's not just a drawing that with no meaning, it has specific meaning. So while you look at this drawing, immediately so this is a high-level description of the watch, and so the boxes are the states of this application. The arrows, or the transitions, essentially what they try to portray, what they mean is the ability for one active, to move from one active state to another when the event on the transition happens. So for instance, if we are in the active state of dead, which is at the top, whenever the BTN, which stands for battery inserted, is triggered, we move into the alive state. And from there, other things happen, which I'll show you, and I'll explain to you how it works more in detail. Is that pretty much clear? I will go more into detail how it works, so if you have other questions, you can raise. But again, from a user perspective, someone that is using a Statecharts from a programming point of view, the way that you can think about it, you can actually think about it as a sort of a black box. That as inputs it has events, and as outputs it has actions. In other words, you tell a Statecharts what happens, and it tells you what to do. Okay? So keep this in mind, and also keep in mind the colors. So you have red for events, which are the inputs of the Statecharts, and actions are the outputs, and are blue. Okay? So here I have a simple example. And okay, when we initialize this Statecharts, within a computer, essentially the interpreter of the Statecharts, what's going to happen is it's going to follow those with the black dots. And what's going to happen is it's going to enter the main, it's going to enter no data, because that's what it says. So the active state will be no data. I'll show you about that. So you can follow the green circle, and here, as I said before, it represents the active state. And now we'll try to communicate, as we do with any library. It has a simple API. We'll try to communicate with the Statechart. And the first thing I'll do is send, again, the red signifies input, so I'll send it a fetch data clicked, and that's what's going to happen. If you notice, the green dots, so the active state, changed from no data to fetching data. And this is obviously because there is an arrow, right? So the fetch data clicked is, since there's an arrow that outgoes that state. And this is, again, going back to the formalism of the Statecharts. Whenever you have an outer state that has inner states, and there's a single arrow from that outer state, all the inner states will transition if that event occurs. Okay, so that's the semantics of this hierarchy. There's other semantics, but this is just one of them. So again, whenever this is triggered, we move it to the fetching data state, and what happens is that we get back the outputs, and this output is to start the HTTP request, and it happens because, as you can see inside the fetching data state, there's two interesting properties. One of them is entry, one of them is exit. And this essentially tells the world, okay, whenever you enter this state, I want to output this action. In this case, it's defined as the start of the HTTP request, so we'll get that as the outputs. And I'll quickly go through other examples. So at this point, the active state is fetching data, as you can follow the green dots. If we trigger the fetch data success event, again, we simply follow, since there's an event that matches the inputs, we transition to the showing data, and what's going to happen? Someone can answer, see if you understand what I'm talking about. Since we just entered the state, right? Because that's the input we got, and we have an entry definition. So what's going to happen in our log? We're going to have two things, interesting enough. One of them is the exits. Since we were in that state before, and the transition caused us to exit that state, we're going to have an output of cancel HTTP request, because that's the exit. But we're also going to have, of course, the entry definition of this new state. Okay?
Is the word entry and exit defined in the paper?
Yes, okay. They are. There's various implementations, so you can think of this as a sort of, the paper is very open. It doesn't define anything. It defines the map of this.
I was just asking because maybe on entry and on exit would have been more easy
in fact,
to understand. Yeah.
There's one implementation that uses on entry. Yeah, absolutely. So again, now we're showing data, and here I want to show just one important point of Statecharts. And the really important point and the crucial aspect of being able to orchestrate events, because again, we're looking into ways that we can orchestrate events, right? And to me, now, what happened is that we're in showing data states, and the fetch data failure event has been triggered, okay? I mean, something has triggered. Maybe there was an old HTTP request that was still ongoing. Something triggered this event. The really cool thing is that that event will not cause anything to happen because there's no event that matches that one. So there's no error that goes outside the showing data of fetch data failure. And this idea of being able to allow only specific events to be triggered is really powerful. Like you can only do when you're in a state, like right now, essentially, I mean this is very simple, but right now the only thing that could happen is fetch data clipped. Nothing else will cause the system to change, okay? And this is really powerful. Like if you think about event handlers, the way we write React components, most events will trigger side effects or actions no matter the state we're in, right? So, yeah. And again, so if I do fetch data clipped, we do the same thing as before, start HTTP request. Now, inside fetching data, if we trigger fetch data failure, there's an arrow that matches that event, and we go inside the error states, and we can again cancel HTTP request and show error dialog. And I continue with other examples. And this is the entry, and then finally, if the user clicks cancel while we're fetching data, we go to the no data state, and nothing happens. Sorry, actually something happens. The exits of the fetching data, and also you can define actions also on the transitions, so not just on the entry and on the exit, but also with that slash syntax, you can define things that happen. And this is similar to if you study state machines to the mealy and more definition. So mealy, I think it's outputs when you inside of the states, and more is on the transition. And here you can have both. So it's combined the two. Okay. So yeah, that's pretty much all there is to Statecharts. Okay. And what I'd like you to concentrate on is this idea of events and actions. So things happen from the outside world. Our app needs to do something. And something is the blue, the things that happen in red. And this is a pretty cool way to manage events. We use the drawing to manage all this complexity of events that happen. So we're getting, I think, closer to a solution. So again, talking about the problem of event orchestration. Yeah.
Just a question on the previous slide.
Sure.
I saw that you use the past for events, right?
Sorry, the past.
The past tense for the events.
Yeah.
And the present for the actual one. So fetch is fetch.
Like here instead of fetched it?
Yeah.
Yeah, I mean that's in my opinion it's a convention. Absolutely, it's a convention. You can, for events, you probably should use past tense. Here, I decided to keep it on the present tense or the whatever verb it is, because there's some connections that I want to do later with Redux and the fact that actions in Redux are present. So, like, it's total convention. So yeah. If we look at the problem again of event orchestration, so the way that I think there's three ways that Statecharts. So now that you know how they work, in my opinion, they help us in three ways. So there's this, they allow us to have a single coherent view on the events that are happening, as I showed you before. There's the idea of blocking events. So that, I don't know if you remember where I showed you there was that fetch data failure in an event that was not supported. So we can, if an event happens and we're in a state that doesn't allow it, nothing will happen. So this idea of blocking events. And finally, the most important one is obviously that this behavior can be visualized. I think it probably beats the rest. I mean, it's so important that we can visualize behavior. That again, behavior. What is behavior? Behavior is where most of the complexity lies. We can have other diagrams that allow us to understand the data flow of our business logic. There's diagram, I'll show you later, there's diagrams for all kinds of things. But the crux is the behavior. If we can visualize the behavior, we have a big win. So okay, just quickly I'm going to dive into how state charts help you. So what is a single coherent view, right? So instead of having the behavior spread across different components, we can represent the behavior in a single coherent way. This is a huge plus for helping us understand, again, event orchestration. Before, with the events handlers, we have, our React components have these events that are triggered all over the place, and it sort of reminds me of marbles. And with state charts, we sort of have this, in a way, it's a very pluggable system. Everything is very well connected. You have a state, that where it connects to, which event connects to what, and what is happening. So it feels much more like this than the marbles. And to actually give you proof of this, I'll show you. Again, remember the red and the blue, okay? So events in action. So here we have, three components, React components, okay? And we have the appropriate events, right? And whenever the events happen within the components, we fire these actions, right? So this is essentially, even with like Elm, with all these complicated frameworks that we built, we still have this events action paradigm, right? Where we have an event, and if this component is visible and it's rendered on a page, no matter what, the request will happen. So the idea of firing the request every time the button is clicked is not really how the real world works. Like the user interface does not work like this. You usually want the request to happen only if we're in a state that allows it. Okay. So going back to I was talking about the single coherent view. Okay. So the state charts allow us to bring all this, essentially all of these things that happen in various components, all in one single place. Okay. So we can transform this with state charts into this. Okay? And now, essentially, we also decoupled the behavior from the business logic of the event handlers. And all the component needs to do, if we have that definition, of course, is trigger the event. It doesn't need to call the action, right? The state chart, so in a way, the component is telling, okay, this was clicked. It's going to tell the state chart there was a response or there was a scroll. And then the state chart is going to take care, not the components. Okay, so this is and by doing this, by extracting the behavior from the components, we describe the behavior in one single place, which is the state chart. Okay? Second one is blocking events. Am I real time? Okay. So, like I said before, state charts allow us to block events, which is another important thing that we deal with every day and we take it for granted is unexpected behavior. And what do I mean by that? I got this from this really good blog post you should read. It's called Pure UI Control by Azilo. And yeah, you can read it. Essentially he's a user interface developer and he's been building interfaces for many years. And so essentially, yeah, for as long as I built user interfaces, regardless of the technology or testing plan, we found an expected behavior in production. Nothing obvious, certainly nothing that anyone would have written a user story about. Instead, the bugs came up in unexpected cases that made you wonder, why would anyone do that? So that's very important, right? But if it's possible to do something, someone eventually will. What almost all these bugs had in common was the dependence on ordering and cases, especially unexpected orders of cases. And when you think about this order of cases, I want you to think back of the log of events that I had before, that we can control exactly when something happens and when the action happens. And this is, we can control behavior, and we can sort of, in a way, not make it possible to perform unexpected behavior because in a given state, only a specific set of events can be triggered. Like I said before, the arrows that go out of states. And by doing this, we're sort of giving a path of the user of things that they can perform. Of course, user being the user interface example, but it can be any reactive application. So by giving this path of things that they can do, it's essentially impossible to perform unexpected behavior unless you define it in Statecharts. So it's an interesting way of thinking about it. And again, the actions, this is just talking about how components work in general, how user interfaces work. The actions executed in response to an event can vary, depending on the previous interaction the user has had with other components, right? So an event should not always trigger the same action. Maybe if the button is somewhere else in the UI is blue, maybe when the user clicks the button, it should trigger another action. This is the nature. Again, going back to the difference between tools, frameworks, and this, is that here there is sort of a fundamental truth into how reactive systems work, and I think this is sort of a truth. Like events and actions, it's sort of the old paradigm. We should be thinking about more event-state action, right, rather than event action. So an action should always be triggered based on the state that it's in, right? And not every time an event is called. And finally, the behavior can be visualized. This is very important. This is just an example of, I think, from the paper from '86, and Harold was describing it. And here it can feel a little bit confusing, right? I mean, you can look at this and like, what the hell? It's not really nice. But actually, because of the hierarchy, I challenge you to think of these as components that can be hidden, right? So, for instance, if this little state here, you can view it without the complexity. You can think of it on its own, and by just thinking of the transitions that get out of this event, where they lead you, you don't have to think about the complexity. Sort of like how we have an interface for a class. We don't have to think about the complexity and the implementation details. But then, if you want, you can zoom in. You can look into. So, even though this can be intimidating, the idea of hierarchy and clustering, being able to open these states up, is very, very important and very, very effective. So that's pretty much it. I mean, I'm going to go through just how we can use Statecharts, okay, in real world applications, okay. And so okay, we're thinking about drawings, right? So now we're going to get more to what the hell this is, right? So now this drawing on the left can actually be represented as a JSON structure. If you think about it, it's just a tree, right? There's some elements, and there's a hierarchy, and for instance, the main state that has other three states in it, it's right there, right? And as you can see, there's a states key that represents the three states, the inner states, and then there's another state at that level, and you can go as deep as you want, right? And I'm going to show you how this can work as from a programming point of view. So let's imagine we have this essentially JSON structure. We can use a library called xState, and we can essentially there's an API with this library. It's called Statechart. It's a function, and when you execute the function with an event, it can only be executed with an event. It remembers the active state it was in, right? So for instance, we click cancel, and because there's no click to cancel supported in the main state, nothing is output. But if we trigger fetch data clicked, which is the first event right there, we transition into fetching data, and we get back fetch data requests, because it's defined here as an entry, right? So again, here we click fetch data click, and nothing happens, etc., etc. So this is the API that I showed you before. And this is possible using this library called State, which is essentially a pure function for transitioning state charts. And just a quick mention of a middleware I wrote for Redux, and that it's available here. And the way that it works is that, how many of you are familiar with Redux? Hands? Redux, you've used Redux? Okay, most of you. So in Redux you have a simple abstraction for essentially managing data, where you have actions that are dispatched, right? And then you have a reducer that is listening, sort of like event sourcing. And the database is changed, which is updates the view, essentially, right? And you have this unidirectional data flow. With state charts, or the way that I envision it, again, this is my idea, not my idea of state charts, but the integration with Redux, is that instead of going directly to the actions, we filter. So whenever you dispatch an action, we filter it. We put state chart in front, and we only let the state chart decide what to actually change in the UI. And this way, we have all the benefits. We have the benefits of being able to visualize. We have the benefits of being able to control behavior. And just really quickly, you can have. Now, I want you to pay attention to here. Now, here it's not just a string. Yeah, it's actually a function. And that function is it's a func, but anyway, it's a promise. It's a function that returns a promise. And that's where our actual thing or side effect happens, right, when we enter that state. And we have, when it's successful, we trigger the fetch data success, which causes change of state. And then the change of state, like the showing data, sorry, this should be showing data. If we enter there, we can use reducers to actually do other things. So it's a nice way to work with Redux, I think. And finally, again, taking a step back from all the implementation. So if we have specifications, and we convert, our job is essentially that. We have to convert specs into code. That's what we. But I also feel that we lose the high-level understanding of our app every time we do that. Whenever I talk to designers, for us, our specs are designs, and it's really sad that they're not connected. Like, I'm not thinking about connecting them through software, having maybe UI tools. I'm actually thinking about connecting them in a sort of from a thinking perspective. They should be more connected. The code and the design. So they're too far apart, so there's nothing really there, And for me, state charts are a way to glue them together. Because the UI, what happens here, can be described as a state chart. And the state chart can be also understood by non-technical people. That's huge, right? You can show a state chart to a person that doesn't know anything about code. And they can understand what's happening. And you can have your code depend on it. So it's a big win for both sides, I think. And just finally, a couple resources. So the Curiosity is one of the most ambitious and successful NASA missions. It is on Mars now, but not everyone knows that the generated code has been part of the Curiosity's rover flight software since launch, and continues to run on board today. Code generated from state chart data is used for auto mover, spacecraft modes, launch mode, cruise mode entry, descent, landing mode. So that's pretty cool. The fact that you're used within a rover on Mars, I find that fascinating. And just a little bit of advantages they found. This is a real-world example. Like I mentioned before, the code and documentation are somewhat always in sync. Similar to the specs. More precise diagrams. I don't even know what that means actually. But it's easier to accommodate changes late in the game. I found this true, I think. It's very important. encourages communication. And this is not only this is of course much more complicated than building user interfaces. But I find the fourth very true also for web developers, UI developers. You know, we should communicate better with designers, and this provides a way to do that. But also the cons. You know, I think whenever someone talks about a new technology or a new idea, they should also mention some cons. And it could be an overkill for a list like state machines, and drawing diagrams takes time. You know? And also there's a big barrier to entry. And finally, this is one also thing I'd like to highlight is actually a code example that at work, and it's a commit that I pushed, and here what I did is I added a new functionality to the software by simply changing the JSON. So like going back to the Legos rather than the marbles. So yeah, so I think it's much more powerful to think about that in that sense. This is just a couple of resources. There's this one that's really good. I really suggest you read it, by Jan Hartz, Constructing the User Interface with Statecharts. And finally, there's also this really good paper from 1988, if you like to think high level about these subjects. It's called On Visual Formalisms. It's really great. It really opens your mind about, like, here I write, and that's my tweet today. I always thought the future of programming would have been centered around techniques that appear with our monkey brain. Instead, we're always stuck in a perpetual, here's the new text-based language or framework cycle. So I feel this is a liberation. So final question, and I'm done. If state charts are so great, why haven't they taken off yet? Why isn't everybody using a state chart, right? I'm here trying to sell you what these state charts are, and why isn't nobody using them? Actually, I don't know why, personally, but two conclusions I've made is that there's a high barrier to entry. Understanding the formalism about how it works, it's not easy, so it could be an overkill. So if you have a small team, I certainly don't suggest you use this. And also, a lot of it has been sort of tied to code generation, and I think this is sort of something that goes back many years because code generation is not needed nowadays. You can, like I showed you before, there can be a JSON that describes the state chart. You don't need to have a sort of this tool that you have to. There's no tool involved. It's only pen and paper and JSON. That's it. So I think that's something new that it's going to be allow more people to use it. And final slide. Like I mentioned earlier, what about all the other diagrams? There's so many other diagrams. What's this have? Why is this more cool than the others? You have activity diagrams. Some of them I've never heard before. Class diagrams. And essentially, they each solve a different problem, obviously. And state charts are concerned with event orchestration and reactivity. So that's really why I chose